KMP, or the Knuth-Morris-Pratt algorithm, takes as input a string, called the text, which is typically on the larger side, and a second string, called the pattern, which is typically on the smaller side. KMP searches for occurrences of the pattern in the text, and returns the first offset into the text at which the pattern can be found, or, if the pattern does not occur in the text at all, it returns a special value, say -1. What is remarkable about KMP is its time complexity, big O of n plus m in the worst case, where n is the size of the text and m is the size of the pattern. KMP is a little bit like a work of art. It has little practical value, but it is truly beautiful, and this is the main reason you want to understand it. Despite not being itself used in practice, some ideas behind KMP do make their way into the Boyer-Moore algorithm, which is used in practice. Therefore, if you are practically oriented, KMP is also worth learning because of this. KMP builds on the so-called naive algorithm, so you need to understand that one first. If you haven't already, watch my tutorial on the naive string search algorithm. It takes about 5 minutes and it explains a lesser understood issue in measuring its running time. You can find the link in the description box below. Just like in the naive algorithm, KMP checks whether the pattern occurs in the text at various offsets. It keeps track of the current offset by using an index called I. Similarly to the naive algorithm, it also uses an index into the pattern, called K, which tracks the number of symbols known to match in the current state. KMP differs from the naive algorithm in the way it handles mismatches. The naive algorithm would forget all information obtained in the previous comparisons. It would simply increment the offset I and reset K to 0. The KMP algorithm does better by not forgetting the successful comparisons. It uses this precious information to potentially skip over some offsets where the pattern cannot possibly occur. Furthermore, it saves on future comparisons by resetting K to a value potentially greater than 0. But how exactly does it compute these updates? In part 2 of this tutorial, I'll explain it in great depth. So make sure you subscribe and hit the bell icon to get notified when part 2 goes live.